잊어도 돼 영원이란 것 속에 잠들어버린 대로 나를 잊지 말아줘 뜨겁게 타오를 때네 곁에 있을게 살려는 그림자가 돌덩이에 지나지 않더라도 밝게 타올라 궤도에 존재하고 싶어 힘이 급해서 헤매 너의 손을 들어줄게 아마 그건 네가 가졌던 힘과 용기일 거야
Good evening. We're back in TIS-100 where, working my way through the TIS-net directory, I successfully calculated the mode of a sequence, several sequences in fact, last week. And I was explaining this to Simon just before I started the stream and then realised I should really have done it on the stream. But so yes, that worked quite well in that it had this thing that calculated this histogram and then did some faff down here that I can no longer remember. But apparently needed 4 separate processes to do it. Well, not really. This one's job was mostly zeroing out the histogram at the start and then reading out the histogram later as necessary. With various bits of silliness involved as well. But next, we have the sequence normalizer, which, well, that's almost normal, that distribution there. That one's not bad, apart from whatever happens in that spike. So there looks like, it's not like there's only one implementation, but there's no obvious like pair of implementations like we got in a lot of the others. So, what is a normalizer anyway? Sequences are terminated with -1. What? Read a sequence from in, find the minimum value in the sequence, subtract the minimum value from each value in the sequence, write the sequence to out.
Right, so it's, yes, okay, so it's translating the sequence so that its minimum becomes 0.
Yes.
But 0 sometimes appears in the input sequence, maybe?
None of those ones have one, but 0 will obviously appear in the output sequence, and therefore they're terminated by -1 instead, because we still have to terminate them by -1. And no, you're not allowed to randomly translate the output endpoint downwards. That stays as -1.
Of course.
And our people meeting one another, who've just managed to run into Randy, I think. We should sign our names, otherwise this is going to be a mess. C. Good idea, M. Who are you people? Do you have a TIS-100, Randy? M. Yeah, I got a TIS-100, yeah. What year is it where you are? I don't know. So... I mean, this feels like it should be a fairly simple one, especially compared to the mode calculation. Like, but we've even got... Like, surely this processor copies things over to that one and remembers the minimum, probably. Or maybe it copies the sequence to there as well, and this one remembers the minimum. And then this one, given the minimum, copies the sequence back out again to out. Like, this feels like it's a half-hour program. I mean, okay, we immediately have the problem that we haven't got enough registers, right? So we'll split. We'll have this one just be a T piece that copies input both into the stack memory node and downwards. Now that's obviously not an entirely acceptable program because at some point it needs to stop. But that's actually fairly easy. It's already loading the value into ACK. So when it passes a -1, it could, yeah. Let's have it do that. So let's just have it when it sees -1, wait until the processor down from it sends it something to say, right, you can start moving again. So that program should just copy the first sequence into the stack memory node, and also have sent a copy down here. That looks good. So now this one wants to initialize the accumulator to the largest possible value. Subtract a value it gets from the thing above. Probably save the value of the accumulator first. And then there's a fairly standard, if the result is less than 0, then we need to do one thing, and otherwise we swap and then we jump back to the beginning of that loop there. Though there is a slight problem that we also need to handle when we get fed a -1, because of course -1 is going to be less than I've just written a maximum finder. That's not very helpful.
Oh, is that not trivial to change around?
I think it's trivial. Hang on. Or have I just screwed this up in some other way? I subtract the new value, and if the new value is greater than 0, then obviously the new value was a more interesting one. Yes. I think I do actually need to have the processor above send us 2 copies of the number we're interested in, but that's not a serious problem. But the issue, of course, is that if you subtract -1, then you're definitely going to end up with something greater than 0, and therefore we actually have to somehow detect -1 early, or we do something extra clever. Or I suppose we have this JRO and the thing above detect it and send us in the correct direction. But let's not worry about -1 for now. So if we go for the really lazy approach, then we obviously take 2 copies into the shower. And we do something like that, and that will then, oh, that wasn't the button I meant, mean that we go, oh, is the minimum 90? Maybe it is. It's definitely not 97, but actually it's 56. Still 56. Still 56. It's -1. So that's fine, except that the minimum of every sequence is -1 because the terminator is -1.
Because actually it is that.
So now we have to explain that no, -1 doesn't count. So, what are the ways we could do this? We could pass... One approach would be to use a JRO in the bottom processor and then have the top processor signal either this is an interesting input value or this is the end of the list. So that adds basically one... That makes the making the decision in the bottom processor really simple. It is probably a bit slow, but it's a kind of pattern I'm used to. Yeah, I think we'll do that. So we'll have it pass 1 at the end of the list, which for now we'll just JRO 0, and for now 2 if it's not the end of the list. This of course means that this processor needs to detect slightly earlier that something interesting has happened. Something like that. So then we stop with the incorrect conclusion that that's weird. Oh yes, because that L, now we actually need to move that label L up to there, you idiot. Right, so now we end up with the probably correct conclusion that the minimum value is 56. So what we probably want to do with that minimum value is send it off to the right and then wait for a signal from the right to say, right, we've evacuated the stack memory node, please start filling it with values with the next sequence. Obviously now 2 becomes 3. We pass the 3 down there. That will crash in precisely the same way, and that stops passing 56 that way, and with the stack memory node containing the sequence in reverse order. Well, that's why they've given us a second stack memory node, isn't it? So that of course means that is of course its own kind of pain, because no, we foolishly didn't stick a any kind of a sentinel value onto the onto top of stack. So let's do that. Check that works reasonably well and I haven't screwed up that. Yes. I'm now having the horrible idea that I don't think I've ever implemented before of actually sticking values that you want to pass to JRO onto a stack in order to like store a program that you might want to use later. Like we could interleave the...
But you could even use it as a return stack. You could push the thing you want to come back to and then branch.
Yeah, gods, yes, you totally... I mean, it's slightly awkward because we don't have any way to read the program counter, so we have to have a bunch of mov constant onto stack, but...
Yes. On the other hand, every call would be at a fixed address, so you wouldn't be able to do it. It would just be a pain.
So we could have perfectly well recursive subroutines in 14 instructions.
This is where you want the challenge of make up a puzzle of your own and answer it, because now you should find something that's useful for.
After the last puzzle I made up, I'm not sure it will be safe. Right.
You could have decided that was maybe too difficult and we'll try a different one.
But it wasn't. It was precisely difficult enough, as it turned out. Right. So but yes, here for instance, if we alternated JRO values and the things we've got in the sequence, then we could save having to carefully check for the sentinel value, because we could just end with a right, you've reached the end, do something different now instruction, at the expense of only being able to keep sequences half as long. So we then end up with something more or less like what we had. So it's kind of inconvenient going, if we want to subtract the same number from a bunch of other numbers. Oh, yeah, we do it backwards, don't we? We negate the thing we want, and then we stick that in back, and then we can repeatedly do swap, sav, sub right, mov, ack down, in order to subtract the same value from each item in the sequence.
Oh, of course, yes.
Which would be brilliant, apart from the problem of running into that -1 at the end. What's the longest sequence we get? Damn it. Slightly too long to be able to double it, to put 2 copies of each, or two stack entries for each entry in the sequence. Right. But we could always make this the problem of the processor below. Like, we've got a spare processor. Parallelism. I had put in a mov nil left in order to signal back to here that it could start reloading. But of course, as soon as we've emptied this stack memory node, we can start reloading, which happens here. So then this node will do a usual jump table thing, and the common case, they're both going to need jump back anyway, so the usual case will be swoop. Actually, we want that at the end, don't we? Will be probably salve. Let's just do what we have to do at this stage and then work out what we end up with at the end of the loop later. Sub up morph, sorry, add up, back down, swoop in order to get a new copy of the thing saved in back, jump L. 4, 5, 6. Good night. And in the other case, when we've reached the end of the list, we just mov -1 down, and then loop back to the start. Right, well that might work. Let's see what happens. Well, that started out all right and then went disastrously wrong. Why on earth is that trying to read something from left? What are you thinking? Right.
Computer doesn't think.
No, what was I thinking?
That's a good question. I can't answer that. No, that's the wrong pill. I do not want to take that.
Well, it started well.
Oh yeah,
And then it started playing really bad techno at you.
So,
it's adding 11 to everything in the third sequence.
and then adding 9,
No.
and then adding something completely stupid.
32. I mean, actually, you don't need. Once you work out that it's adding the same thing every time, you just look where the zero is in the proper output.
Oh, right, yes, of course. Adds 11, 9, 32 and 7. Having worked correctly for the first 4 sequences.
That is quite odd. Well, odd.
Doesn't look like there's anything obviously weird about the... I mean, that sequence only has 1 element. No, it doesn't, sorry. It has 3 elements. How very strange. Right, right, I think I'm going to have to single step this through that because I couldn't see any obvious, like, we're ending up with spurious values anywhere. So, we seem to have decided that this sequence's minimum is 1, which is incorrect. Are we not? Are we missing? Are we missing a jump somewhere?
Have all the previous sequences had
A
their-
decreasing minima.
Yes.
Yes, I think they had. And we were actually choosing the minimum of every value we'd seen so far, and not the minimum of the current sequence, because I think we never had anything that actually allowed us to jump back to the top of this program, because there's no label there, and you can't fall through the bottom of the program. So, where's the bit of code that should do that? That's there, and yes, it just falls through and doesn't do anything useful.
They're really helpful.
Yes. Yes, we are.
Right, let's actually have it reset its minimum counter this time. But this is like properly parallel, this is. Admittedly, one of the operations we have to do is just reverse the list, which is kind of inconvenient. But yes, right down at the bottom of the cycle counts, pretty good node count and only slightly embarrassing instruction count.
It's not way over there on the great big blob of
It's not. Yes, we didn't hit that spike.
Lots of people did it very strange way. We don't know why.
Right, onwards. Image test pattern 3. They were creating a portal. What do you mean they? They want to take from us. Take what? Everything. TIS-100 is part of a larger system they built. Built to take from other worlds. Right. Okay.
Well, given that, I think that thing there that's a cross between the I don't know, the 2001 psychedelic sequence and the elite docking seems like a very appropriate image.
Right, yes, I can remember doing this one. I think when I've done this, I've mostly just ended up encoding most of like how what the picture shows, rather than trying to be very clever about it. So I can't quite remember. So I'm going to have a quick look at the instructions for how rendering this stuff works again. How rendering the things to graphics works. So the sequences go X coordinate, Y coordinate, sequences of colours moving to the right, end. Is that right? Yes. And in the past we've often gone for using run length encoding for this kind of thing. So but we generally need just thinking what the last step of this pipeline should be. So probably the last step is something that just goes
Sloblocks.
is it X then Y?
Gareth?
Yes.
Are you likely not to go to bed for the next hour or so?
Before that.
Because I failed to put my breakfast on, and if I put it on, then
I'll be going to bed before that.
I can't hear you.
I'll be going to bed before that.
Oh.
I'm tired.
Are you likely to still be up at 11:30, Ben?
Yes.
Okay. Thank you. And can you also rescue stuff from the oven if it peeps?
Yeah, I can manage that.
Thank you. Right. Otherwise, I have to make porridge tomorrow. and
People
that
on the stream, remind me if
Getting
the
up.
oven beeps that I should go and rescue something from it.
Whatever turns out to be in there.
Yes.
And also put the next thing in. I'll leave you a note with the thing. Back on that. Thank you. Right, space.
So then we want...
Can I borrow you to talk, please?
So that's all very well. And then we do, like... But we need to do mov thing down like 35 times. FX looks up the correct value of 35. 30 times. Which we obviously can't do just with the counter. Unless I suppose... Well, I suppose if you've got back, we could do swoop. Thing, swoop. So I think, given something that feeds it pixels, that will now go wrong. Ah, yes. Put in the sequence termination thing. No, that's still not working correctly. Faster. Oh, stoked. Also, we need a line feed. Right, so now if I can get the rest of the processors to generate me a suitable pixel stream, that will render them all on the screen. Now, I'm not sure whether that's the best approach. Maybe it would be better to take advantage of the symmetry and do it coming inwards from the top and the bottom at the same time.
I missed the setup. What's the output?
The goal is to draw this on the screen.
I saw that, but what's the interface to getting things onto the screen?
Uh,
You had to feed them in a raster order, but then you said going from both sides.
So yes, well, but so you put in x coordinate, y coordinate, sequence of pixels to display rightwards starting at that xy position -1.
Right.
So what I've done here is implemented something that just takes a stream of pixels and draws them on the screen in raster order, which might be sensible, but on the other hand, do I maybe want to do the top line and the bottom line in parallel? But that's going to be a lot slower if I bounce between them repeatedly, because I have to send coordinates and a -1 after every pixel. On the other hand, it's not exactly a very complicated pattern, so maybe I just generate it once forwards and once backwards. Or, of course, maybe I have...
Too far like that.
Or, of course, maybe I generate it twice forwards in succession and have the output processor go down from the top and then up from the bottom. Or out from the middle in each direction in turn, which would probably give me the best of both worlds. But in that case, let's try to draw this pattern the top half of this pattern and then see if it's easier to draw the bottom half of the pattern by doing that backwards or by rewriting the output routine to enable me to run it twice. So, I mean, one approach here would be to have... I think then what we want is a processor that has a bunch of little routines to do useful things. So, for instance, it could have a give me n white pixels routine.
Useful pot to put things in.
Oops. Give me n black pixels routine, though of course black pixels we don't have to draw because the display starts black. But our output processor has hidden that possibly useful fact from us. I'm now having even weirder thoughts about this. And I kind of want us then to have a give us n alternating pixels routine, but I haven't got room for it. And that's making me think maybe what I actually do is something truly horrible. No. Maybe. Like, could we actually use the any input on here to have multiple different processors feed input in sequence? So the kind of awkward thing there is that we've got 3 processors that could feed input to this one, but we'd have to use 2 more processors to synchronize between them. That's like, I don't want to burn 2 processors on synchronization. Well done.
Oh, a lot of that.
3, 4, 5, 6. Well, it's obviously incorrect, but it kind of demonstrates some possibilities. On the other hand, it's blatantly going to take far, far, far too much program space if we just do it like that. So so maybe now we want something of a that's at a slightly higher level than that does the next thing. So hang on. Oh. Wondering if we could do a slightly cleverer thing that what if, for instance, we had a single operation here? Ooh, would this work? If we had an operation that was given a number, emit essentially that the correct row from the display, from the target display.
Oh, then you could send it increasing and decreasing sequence.
Yes. So it would want one variable that kept track of whether it was emitting black or white at the start, and then it would need to count down across the middle, and then, no, I think we might, how about if our primitive operation at the next level up is actually just given a sequence of numbers, emit alternating bands of black and white in those lengths, because that's quite a simple thing to do.
So for the middle row, you said 1 1 1 1 1 lots 1 1 1 1 1.
Yes.
In
And
fact, for every row you said that.
yes. The only slight problem is that the wrapping at the end would have to have a 2 in it, or a 0. A 0 is probably easier. Except that all my loops are written on the assumption that in this assembler it's much, well, in most assemblers it's much easier to write a minimum of 1 times around loop than a minimum of 0 times around loop. Yes. So we may as well start with white, I suppose. I mean, actually, that's almost the program I wrote before, isn't it? I just need to remove the JRO at the top of it. Hit Control Z repeatedly until the old program comes back. Because actually, I pretty much wrote that. I just want to go remove that JRO, remove that jump back up to the top, and that jump, and the unused labels.
Of course, if you've got a thing that sends the length of alternating bands of white and black, then you can feed your run length encoding into that, because every row is formed some number of ones, some number of things.
Right, there is a note on the work surface for what to do when the oven beeps.
Some number of ones in between. How about this as an alternate design? The end processor just spits out the whole grid in raster order, absorbing a sequence of integers that say, do I change colour or not? Because then every straight section is a bunch of zeros and every bandy section is a bunch of ones. And then you can feed a run length encoder into that really easily.
hang on, the very output processor. So I think you're wanting to replace this processor rather than this one, because this one has to be able to work out when to emit new lines and such.
Oh, you can't wrap round in the...
Yes, there is no auto wrap. So I've implemented this processor implements auto wrap.
Right, okay. That's slightly more annoying.
So if you but on the other hand, at the moment this one expects to receive a sequence of run lengths. This one implements auto wrap and has no spare registers. For instance, to record whether the current output pixel is black or white.
Yes, I hadn't understood that. I wasn't really thinking so much of terminal auto wrap. I was thinking more in terms of like frame buffers. But yes, you're right.
I'm just proving that I can't actually cram the entire thing in. Well, that's wrong. I've got too many ones, haven't I? Yes. And then it'll all go wrong. What? I still can't get this right. Why is that move MOV 30? Oh, MOV 31, MOV 28. That'll be better. And then that one's somehow wrong as well. Okay, this is a surprisingly fiddly MOV 2, MOV 1, MOV 26, MOV 1. Yeah, okay. I have made a middle-sized pig's ear of this, haven't I? This is so that I can get a feel for what kind of data I'm going to need to feed to this thing. Yeah, okay, that one went wrong as well, but that's because we wrapped round. Right. But it starts okay. But there is this slight fiddliness that because I can't emit zeros, I have to jump through stupid hoops. Actually, maybe I don't need to jump through stupid hoops. Maybe I generate a new stupid hoop, and I say that our terminal is 31 characters wide, and then we just send a 1 at the end of each line that doesn't get displayed because it's off the right margin.
Oh, we don't have the stupid terminal normal auto wrap and keep overwriting last character.
No.
Well, I suppose if you sent those,
Right. So then I emit some number of 1s, possibly 0 ones, a gradually decreasing number, and then some number of 1s, and then a 1 to terminate the line. So if we do, so here we'll have, that's obviously wrong. We need some frass in here that I don't know what it is yet. That's emit the alternating colours. But since the first line doesn't have any alternating colours, I'll implement that later. Really need the alternating colours to have a general thing for emit the alternating colours bit, because I need to do that twice. Well, I know. Okay, no, oh gods, no, I don't. I need to emit like 2n plus 1 alternating colours or something. Oh, but I've conveniently got that 2n. It may actually just be 2n alternating colours, which might be fairly easy. Except on the first line, but there conveniently n is 0, so if I accidentally emit twice as many as I need, that's acceptable as well. Or half as many, either's good. 0 times as many. Right, okay, don't get distracted by that. Let's get the first line correct first, which is really trivial. Though maybe I actually count up rather than counting down. Actually, it occurs to me, rather than doing MOV 30 AC, let's start, because then we don't have to do that at all, and then say but then of course we do need to go well, that might be correct or it might not. It's really very hard to tell. Let's write the alternating colours bit then. So that does something like I suppose that's actually be slightly quicker if we do it like that. So that's not quite what I was intending. I think I've forgotten to invert something somewhere.
That is more exciting than necessary.
So when we come in here with our counter beat, well, it probably wants to be 2. We probably want to make it 2 rather than 1, but that will still emit the wrong number, but it'll be a closer number. That will then go back up to there, and then yes, we need an extra swoop here, don't we? That's where it went wrong. I mean, that's a nice new pattern. It's not correct. Right, I think I need to keep slightly closer track of where all my values are. Like, why have I got 2 salves in quick succession here? That's obviously stupid. So we start with the accumulator. Well, the kind of canonical value of the accumulator is the total of the number of extra stripes at something like both the left and right ends of the current line. But I think it's probably more at the right end of the last line and the left end of this line, which might mean that it has to be initialized to like -1 or something. So initially we should emit there will be 0 of those, so we don't try to emit any stripes, and we add 30 to it, and we emit the first line of 30 characters. So let's just check the sequence of where things end up. So we save that into back, so then back contains the current counter. We jump to X, which does swoop sav, so back still contains the current counter. We then calculate the run length we want, and then swoop, increase the number of stripes, jump back to the top. Well, that bit looks good. That loop should not have a sav in it. That's where that goes wrong. Rather, that sav should be here. Like, I think we've probably still got an off by some number error. But maybe not. I mean, there's still a problem that this will just keep going past the middle of the screen.
But it's doing well so far. It's actually believable. What will it do when bits collide? Will they collide?
I'm not sure. I think it'll keep counting, so everything will go weirdly overflowing.
I'm now confused to death.
But it did the first half of the screen correctly.
How many instructions have you got left to make it stop and start going backwards? What are you doing to transition from one line to the next?
This one does nothing. It just keeps emitting. It emits a run of alternating pixels that runs off the end of one line and onto the beginning of the next line. That's why there's an add 2 there, because that alternating row of pixels gets 2 pixels wider each line. This in particular means it doesn't even have a moment when it reaches the end of this line, in that it goes essentially straight from there to there.
I
Which
suppose you could try the add 2 and the jump out. into an add left and a JRO right, and then have those processors feed in a bunch of 2s and go back to being a bunch of -2s. Actually, maybe you don't even need the JRO right.
Yes, actually, if you just had something that counted down feeding in 2s and then counted down feeding in -2s, that would do quite well, yes. So you just do 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just try this. Mov 9 at mov loop, in which we mov 2 right sub 1 JNZL, and then exactly the same thing, but with that being a mov -2 right. And obviously a new name for the loop label. I suspect this will go slightly wrong at the transition, and we'll have to adjust the value of 9 appropriately, or something like that. Or it turns out, actually, we probably need a 0 in there, don't we? Because the 2 middle lines are identical. But if we'll run it and see where it goes wrong. Yeah, so it definitely goes wrong, and it goes wrong by going slightly too far, among other things. I mean, I think there may also have to be a -1 at some point. So, let's just go for the simple one.
Run that fast and see what happens.
Whee!
That's entirely different.
So there is a slight problem because
But does it matter that it's kept going?
that's acceptable. I think we win and I'm now having horrible thoughts about a really, really trivial implementation. We win the moment that the output image is correct. So I'm now just thinking of one that repeatedly increments the output image until it's correct. That doesn't work because you can't read the output image, unlike it is in Shenzhen.io. But so you can do something that gradually mutates the output image in some way that is guaranteed to pass through the correct value.
Grey code. Flip 1 pixel at a time. No, you do need to keep more state for grey code. Yeah. In fact, with the amount of state you have available here, it might actually be quite a challenge to make the output.
To get that to go through every possible thing, yes.
I mean, obviously you wouldn't run it. You'd prove that it worked, but I think you might find that was a challenge.
So, yes. So that goes correctly up to this line and then does a new kind of wrong thing.
I think you might have to use an odd number.
Yeah, well,
Because every time you miss an even number,
the problem is that
the length of the innermost colour run changes, and you need it not to change between the centre 2 lines.
oh. Yeah, the problem, I think that we have slightly too little flexibility here. Though I'm getting patterns I was not expecting.
Yes, that one's quite exciting. That looks as if a cellular automaton of some kind is running from the bottom up.
So while we have a lot of good patterns, I think there is a slight problem that essentially this can't be reversed correctly. Largely because we emit 2 lines worth of alternating colours at once, and what we actually need to do in this gap is to emit, and the number of alternating colours we emit is determined by the values of both of the rows, even though we only use one of the rows' values to calculate it. And that's why it all goes wrong as soon as things aren't precisely counting down by twos. So one approach would be to emit the bands of alternating colours in two batches and correctly fiddle the numbers in between. The other approach would be to actually have two places where we can adjust the counter. So that's the other swoop sav, isn't it? So let's assume that's the other place we might want to adjust the counter. And we usually adjust it by 0 at that point. But in the middle, we might want to adjust it by something else. So let's first of all not do that and just check that that still gives us the same wrong behaviour. Good. So now I'm just going to apply random perturbations to my program until it works correctly. No. Though that's kind of unhelpful because that appeared to be one of the different error patterns I got before. No. Ooh.
Well, I suppose another thing you could do is, because this draws the top half correctly, let it run until it gets to the middle, and then cause it to reset via JRO to a thing that clears its state and makes it start over from the beginning, and meanwhile send a signal down through those two unused processes to the one at the bottom that says now start going from the bottom up.
Yes. We might be able to do better than that, in fact, because this might be able to detect the correct position. Okay, I may actually have to think about this rather than just thrashing at it. So maybe that's the wrong point at which to add. So let's actually pay some attention to this rather than thrashing randomly until it works. So we now have an additional adjustment point, which is not actually in a very helpful position. Is it? Oh, maybe it is. Oh, I think I may have got this backwards. So we now have 2 points where we can adjust the counter. One is just after we emit the main solid band of colour, and one is just after we emit the alternating bands of colour. So normally we don't touch the counter after the solid band and before the alternating band, and that gives us correct results. So, but when we reach here, we want to adjust we want to not change, well, we want to not change the counter in either state, do we? But actually that's not good, because since we didn't change it there and that gave us one thing too long, we want to subtract 1. So I think first, I'm wondering if actually I'm doing this. So that looks like it should be right if, pause so that flickering doesn't distract me. So we reached there, but that looks like we actually we didn't correctly, because we still emitted even more things, and we reached there before we started doing anything interesting, or possibly there. So I think one change we want to make is to reduce that 9 to an 8. so that we can do the clever things separately. Oh, of course, it's fine for us to overrun the end of the program. We don't need to counter it for the second loop, do we? So right now, when we got to... So we got to there okay, but then it looks like we actually emitted slightly too long a stripe. So maybe I've got my numbers the wrong way around. Maybe I want that to be a 0. Right, that's now emitted the correct striping out to there, and indeed has got a little bit further, in that this row is now correct. This row is correct, except that the central stripe ends up 1 pixel too short. So... yeah, but not as confused as you might think, I suspect. Actually, what I'm going to do is I'm going to work out the sequence of numbers I want, and when it looks like it's turning into a loop again, turn it into a loop. So that's fine. Probably.
That seems like a thing a compiler could do. Compilers have a limited ability to do function outlining, where they spot a thing that could be moved off into a subfunction to save space and do it. And loop rolling seems like a thing, an optimization in the same space. That
There we go. I mean, that appears to have been a relatively good implementation, really.
it does, doesn't it?
Despite the slightly silly approach I took to it. So apparently you
Well, I
can...
think we discussed some sillier ones.
Yes.
Well, I know you have to stay up because of this oven, but I have to walk home, so I think I'm going to start heading.
Right. I should probably run that at normal speed just to complete it properly. Yeah, normal speed. It is actually quite slow. I suppose, yes, you could. The way to do this faster is to somehow avoid emitting all of those black stripes.
Yes, I mean, my first thought when I saw this was you want a processor that knows how to draw a horizontal stripe, and a processor that knows how to draw a vertical stripe, and
Yes.
tell them to draw a bunch of those, but you never quite know whether these things that seem logical to a human are going to work out optimal in TIS-100 land. I mean, apart from that, you couldn't have both of them in the output processor very easily, so you might find
No.
you had to have the output processor just funneling anything from the left or the right as appropriate or some nonsense. I suppose it could funnel in from any, couldn't it?
Yes, I did consider that. Yeah, okay, we've run it at normal speed. I'm bored now. So yes, there's definitely some faster approaches available. Another image test pattern.
Or I'll at least look. Oh my god, what colours are those?
Black, dark grey, light grey and white.
From here it looks faintly sepia, but I think that's just an artifact of being at a slight angle to the telly.
A portal meaning what? Like quantum gate? That's the only explanation that even starts to make sense. See, These TIS-100 machines must be entangled, I think. C. Somehow they came into our world from a different one. C. How? M. Through the gate Randy was talking about. Randy, you there? Right. I mean, this feels like it should be a pretty small program, really. Like, we only have 2 different patterns we need to be able to output. And one of them goes... 0, 1, 2, 3, and the other one goes 2, 3, 0. Oh no, there are 4 patterns we need to output. Yes, 0, 1, 2, 3, and 1, 0, 3, 2, and then 2, 3, 0, 1, and then 3, 2, 1, 0. And I'm kind of going, I could copy about half of the code from the previous program. Does copy and paste work between segments? Yes. So we can use the same auto wrap code.
Removing this time the extra character at the end of the line.
Yes.
Oh, the line's not a multiple of 4, is it? That's
No, so we do have to resync at the end of it. Well, actually, maybe that... No, the problem... And the lines don't... Each line is a different sequence from the previous line. They're not... The lines are not all shifts of one another.
Yes, that's true. You'd have to...
The third line is a shift of the first line.
Yes, if it were a multiple of 4, you'd still have to change your mind at the end of the line anyhow.
Yes. Because, like, I can make it a multiple of 4 by just throwing away a few characters at the end of each line.
It is a bit frustrating that this is a program that would be so easy if you had bitwise operations.
Yes.
This is designed for bitwise stuff, and therefore they're making you do it on a regular arithmetic only decimal processor.
That's not right, but it's gets the first line correct. But the thing is that so then we could have it count down, but the thing is that will add so much code that we don't have enough room for all of the 4 things that we want to do. On the other hand, maybe that doesn't matter. I mean, we could interleave those ones that are shifts of one another by jumping into the middle of the loop. So so close. Hang on. So close it'll actually work. So that, I think, will just repeatedly output. Oh. No, because this is wrapping now, isn't it? That's inconvenient. I actually want it not to wrap, but sorry, I've just had a thought. So those lines are all correct. So if we could then realise that we need to jump to the other half part way through and have this reset to the top. Then maybe we could do it in like 2 pieces. That's not what I intended. By quite some distance. So that swoop pulls the line counter out of back. Then we add 2, and then, oh no, that's the wrong way round. JGZT. Let's try that. Right, so that's still drawing those 2 lines the right way round. Good. We will then need some way by which we flip which kind of line we're emitting. So it does seem to... I think I've probably got the value of 21 wrong there. Let's try making it 19 instead. Okay, very fast if I have it in fast mode, so I think I do just have to watch this. Okay, what? Okay, I don't understand why sub 19 there should cause that radical... Oh, because we then add 21 later. Stoats. Just trying to avoid it having a gratuitous bit at the beginning when it... at the end when it spends spends some time emitting a line that isn't being displayed. Still emitting a line that's not being displayed. Try 17. And this time change it in both places. Probably mute things while there's that terrible screeching going on. Yes, Jacob, the beeping has indeed beeped, but it's at precisely the same pitch as the weeping. But we can hear it now that we've opened the door, so maybe I should go off and deal with that, and I'll be back in a moment. Weeping has mostly stopped now. And also breakfast has been rescued. Just doing some sums in my head. Let's start with 10 and see how it goes. 1, 2, 3, 4, 5, 6, 7, 8. Well, it's a good start. We just need to reduce the value of 10 by 2. I don't have a very clear idea why it should be 8, given that I thought we would divide. Am I confused about the number of lines? I am. It's 18 characters high and not 22 characters high, right? That makes a lot more sense. Okay, that's kind of weird. And it now, yes, occurs to me that, like, why are we out? We're outputting 8 copies of the thing here, and that might be sensible under some circumstances. But we're essentially doing 32 what? I think we just want to fiddle these numbers a bit until they do the right thing. So I don't think we actually want to do this like 2 separate sets of looping. That's just silly. I don't know what the number should be, something like that. You'll notice the top processor is now completely redundant. So now we just need to get 64, to replace 64 with the correct value, if we're lucky. Oops, no, I should have paused then. Right. So first, the synchronization is correct. That second line is coming out right. The problem is though that we switched patterns slightly too early, so we should switch patterns 1, 2, 3. If we switch patterns 3 cycles later, that's going to be like not quite right, isn't it? That wasn't quite what I wanted. I want to see how it wraps. I mean, it's kind of fun if you just let it go fast. But none of the output states is correct. So let's let it run slowly. So yes, it gets into the. In this case, it produces the wrong output in 2 pixels, and it also switches back again in completely the wrong place. It's not like it needs to worry about what happens then anyway. That loop can just run forever. But the thing is, if we change this to 68, I think I know how I fix this though, and it's a fairly trivial fix. If we change it to 68, then it turns out that's wrong as well, and it draws the wrong thing there, because the problem is we want to go round this loop 67.5 times. How do you go round loop 67.5 times? You Duff's device it. Well, you kind of Duff's device it. We'll have a label called D for Duff, and we enter the loop by jumping to D. Now that's obviously going to end up with our loop in completely the wrong order, so then we change it from 0, 1, 2, 3 to 2, 3, 0, 1. And that will not do the right thing, because I also need to change it down to 60. No, I do want it 68 because we subtract a half by jumping into the middle of the loop. So this might actually get the crossover correct. Yeah, ooh. No, that's not right. I mean, the crossover is correct in that we don't get any blatantly wrong pixels at the crossover, but we've ended up with the wrong pattern nonetheless. Because we're actually entering that second row in the wrong place. We want to enter the second row just before the 2. So it just before the 2, just before the 1. So we want that to go 1, 0, 3, 2. Right. Let's try that one. I'm now wondering if you could have some fun by drawing all of the whites and then all of the greys and then all of the other greys and then all of the other greys. But I think given the sheer number of coordinates you'd have to generate, that would be quite slow. That looks like the pattern's correct though, doesn't it? Yes. And right in the middle of the cycle count, but doing it in 2 nodes is apparently slightly impressive. Doing it in 26 instructions is pretty impressive too, apparently. Oh gods, I kind of remember this one. I'm also looking, now we've got the titles for quite a few of the remaining things, and there's T20 node emulator. T31 node emulator. Isn't the T31 the one that we're not allowed to know about? No, T31 is random access memory. Oh right, it is T20 stack memory. Oh no, T30 is stack memory. T20 is reserved. Oh, and T21 is a basic execution node. Right, and T20 is the one that we don't know about because we have no documentation for it. I think I got up to like the back reference reifier, I think. I can't quite remember. So I think I may never actually have finished this part of the game. I remember doing this one though. Right, start at the upper left of screen, read angle in degrees from in, read length from in, draw a line segment with specified angle and length. I don't know where Randy went, but I think I got it. By using TIS-100s as a tool for observation, some other world was collapsing the wave functions of quantum superpositions and entangling enough matter to open gates to parallel worlds. I skipped through steps there, but you follow. Yes? Not really. Funnily enough, Mosley, you're in Copenhagen, huh? Never mind, don't worry about it. Thank you, yes. Right, so we get, as inputs, 0, presumably meaning east, 8. So we go east 8, 270. So angles go from east being 0 anti-clockwise. Bloody mathematicians. 275, 0, 11, 270, 13, and so forth. Right. It does rather look like we only have to support multiples of 90, yes. So, it kind of feels like the last step, ideally, if we've got enough... No, I think the last stage of this is something that maintains both an x and a y coordinate and receives deltas that it uses to emit one step in some direction. So it would do something like mov ac down, swoop, mov ac, actually mov ac down, add up, say, mov ac down, add up, swoop, mov 3 down, mov -1 down. So it essentially repeatedly just emits x coordinate and y coordinate, print one character there, and move the cursor in a direction given by a delta, by a pair of deltas emitted by some other node. So we could, for instance, go and we would draw a horizontal line. We could go like that, and we draw a diagonal line, and so forth. So that seems like quite a good primitive, because now we can emit those lines as sequences of pairs of numbers. It might be that we could do something cleverer by, rather than doing this as... Nah, but we've got all this swapping to do now. I think that's actually quite a nice design. I was wondering if we could have different bits of code for each direction down here, but we haven't really got the space. So let's stick with having pairs of numbers that we pass. And then we'll then want something that knows... I mean, I suppose an extreme version would be something that, given one of the angles, would emit one of the correct pairs of things. So we could go... Well, it was a good start, but we haven't got the space. This is kind of unnecessarily complicated, really. Now, really, 180 is not south. 180 is west. .90 is up, so that will be LZ. That should be 13. So we do seem to have rather a lot of like administrative jumping around here. I feel that I could probably do better than that. But these numbers are awkward. That doesn't work. Oh, label is already defined. Which one of these is wrong then? It's probably that one, isn't it? I've got all the numbers wrong as well. Let's carefully work our way through this. So east is 0, yes. E mov 1 down 1, yes. Oh, sorry, 1, yes. 180 is therefore the inverse of that, which is west. W moves 7 down. 1, 2, 3, 4, 5, 6, 7, yes. N is therefore in between those and is therefore less than 0 once you've subtracted 180 from it, and that's n, which causes us to jump to there, which is 13. 1, 2, 3, 4, 5, 6, 7. Hang on, I've lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No, that's not right. We want 10 for n. And we want 4 for s. Right, let's try that. Is this all full of off by 1 errors? Is my picture turning out slightly too big? It is. Right, so because I think it counts the starting pixel as part of your distance, part of the distance you're meant to measure. Okay, we reached the end, but we didn't win. We failed by not drawing the last pixel. Bah. So I think the problem is that we have to do we essentially are expected to do a 0 move at the start of each run, because because it looks, I think that's correct, except for that last pixel being missing. Like, it doesn't look like there are any other errors there. But so the obvious thing is, well, obviously the last pixel is part of that previous line. So we make each pixel, at the moment our lines include their starting pixel, but don't include their ending pixel. We could swap that and have them include their ending pixel, but not their starting pixel pretty easily by swapping cursor movement and printing. But that would mean that the first position was wrong. So we actually, I think, want to repeat that first pixel each time, which is a pain. Unless there's some clever way. Oh, we could just have it move one. No. I was going to say we could have it, because it starts at 0, 0. And we could, like, move it to -1, -1 at the start. That would be ugly. No, right. So what I'm going to do is I'm going to say we move the cursor first and then plot a pixel, and that will work, except that it will miss out that top left corner. So let's just let that run and make sure that it ends correctly, yes. But the beginning is a much easier point at which to do something interesting. In particular, what we could do is emit a 0, 0 move at the start. So that causes us to emit that first pixel at 0, 0 before we start drawing. And I think now we're going to do the right thing. And because everything in here jumps back up to that label rather than to the top of the program, because I put a gratuitous jump T in there that we didn't need. That now works properly. Jacob has tested the thing by ripping off screenshots from the video. So yes, that seems to be behaving itself. I mean, like, we perfectly well could do at least 45-degree angles quite easily in this setup. We'd have the problem that we wouldn't have enough space in this processor to remember all of the angles. So we'd probably have to come up with some cleverer way of doing very rough approximations to sine and cos. It's mostly just sine and cos rounded to nearest integer, isn't it? Which isn't very rough. Like, obviously, that's what we should have. Is a math coprocessor that does our sine and cosine approximations. We declare that sine of 45 degrees is 1. Well, it wasn't brilliantly fast. I think you could do faster by doing your horizontals much more efficiently. But on the other hand, it was very easy to understand. And like, minimum number of nodes and a pretty minimal number of instructions. Right, one more I think tonight. Oh God, we're building a terminal emulator. Suppose there's a world similar to our own, except quantum technology at with quantum technology at their disposal. Haha, this is like Sliders. Like what? Sliders. It's a TV show. It comes on later in the 90s. It's about parallel universes. Oh, cool. Not really. So, terminal emulators then. We get 2 stack memory nodes for this, which feels like it should be unnecessary. But possibly that's enough space to remember an entire line of text so that we can render a whole line at a time. Which is probably the most efficient way to do this. I think last time I did it by rendering each character separately with like cursor movements in between. So maybe this time I need to do this by accumulating an entire line in memory and then rendering the whole lot all at once, or possibly even accumulating a whole line in memory, then reversing it, rendering the top half of it on the fly, and then reversing it and rendering the bottom half. So we could have like I feel that we probably end up with a processor that's the top line lookup table and the processor that's the bottom line lookup table. And we don't have many characters to render. Like we have numbers 0 through 4. I'm actually going to label these unhelpfully for now. I don't actually know. We know that 3 looks like that. That's a 3. A 4. Looks like that. A 2 goes... What? 3. 3. Goes 3, 0. Well, 1 is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th character. And a 0 is the other character we haven't seen yet. Sure. Is character 1, 2, 3, 4. Oh, and 0 is a new line, so we don't need that. So that processor, let's just reorganize this into a sensible fashion. Given 3 times the input plus 1, no, sorry, 3 times the input minus 2, assuming that something else handles new lines, will output the 3 pixels of the top line of the characters. So similarly, we could do the 3 pixels of the bottom line of the characters. 1s go white, black. 3s go white, black as well. Sorry, let's just make my life easier. Let's do this like this. So a 3 is blank thing blank. A 4 is thing blank. Then a 2 is thing blank thing, and a 1 is blank thing. Right there. Yes, 0 is a new line. There. So then, yes, you pass in 3n minus 2 into here. Right, so anyway, yes, this was the one we were doing. Well, so bottom lines go 3, 0, 0, 3, 3, 0, 3, 0. So that's our character, our font ROM. I wonder how we use this. So obviously we need to keep. We have a kind of input cursor and a kind of output cursor. Though the kind of output cursor may not be very relevant. So we want to alternate. Well, we have. So to output an even line, rather to output the top line of a line, top pixel line of a line of text, we really want, yes, a character generator that knows how to output a line, don't we? Which is fairly simple. It needs to know what the line number we're currently on is, and then to take a sequence of character values and pass them to the right, and spit out whatever comes back downwards. Only it can't pass precisely the character values, though maybe it could. Like we got enough space to do that? We haven't got enough space to multiply by 3, have we? Multiplying by 3 is a pain. Oh, something's beeping. Gareth said he would be in bed by now, so I should go and sort that out. Back in a moment. Hello again. So where were we? Ah, yes. So yes, I was going. We have to multiply by 3, do we? which is slightly painful. And subtracting 2 is easy enough, and multiplying by 2 is easy enough. You just add a number to itself. But multiply by 3 and subtract 2 is kind of inconvenient. I have a horrible feeling it might be best to share this job between 2 processors. And I'm kind of going, is there a way that we could make that only need 2 instructions per value? Maybe, actually. Oh gods, this is silly. So obviously the second pixel can only take 2 possible values. Oh no, we haven't got... yes. So we could, instead of doing a mov and a jump to one of 2 places. So we could have a label E0 that means emitter 0 and the end of the line, and a label E3 that means emitter 3 and then the end of the character. And E0 can conveniently be here. And that now means that we only have an offset of... We've reduced the number of instructions by 1, and we only have an offset of 1, 3, 5, or 7, which is easier to calculate. And frankly, if that turns out to be too painful, we have an offset of 2, 4, 6, or 8, which is even easier to calculate. So let's do the same thing here. That's a jump to E0. That's a jump to E0. That's a jump to E3. That then gains a label E3. And then we have a jump E0 is mod 0 left. Right, okay. So that's some slightly cleverer character ROMs. Now we've got enough space that we can stick the character code in the bottom of one of the ROMs. Right. Maybe we could stick it at the top. It would look better there, wouldn't it? There. So, what now? Well, let's just try writing some really trivial code that tries to render some things. So this will try to render the bottom line, which is not very helpful. Well, that didn't work very well. Oh, yes, because that really needs to be slightly cleverer, doesn't it? Of left, ac, add ac, sub 1. Yeah, that didn't quite work. Oh, yeah, we might want to do something with that value. Okay, that froze up just as soon as I stopped single stepping it. Oh, we need to move, and each character has 3 pixels, of course, because it has that pixel of margin at the right-hand side. Right, so that's probably correct, isn't it? Let's have a quick look. Sorry, I just moved. So it should look like thing, point off blanks, thing blank thing, blank blank thing, blank blank thing, blank blank blank. Yeah, that looks good. Right. Have we got enough space in these processes to do that that add and multiply faffing? So that would become instead, I think we have if we move that comment out of the way again. Only it's actually cheaper to remove that sub 1 and just stick a nop in there that never gets executed. So that would then mean that could just become mov left right. Back up there with you. Right, so now we have our 2 character ROMs. Inconveniently, they output data in different places, but for instance, we could shuffle them around so that they're in 2 positions adjacent to the output processor, couldn't we? At which point maybe we end up doing the sums in the output processor instead. But it does also need to have a way of resetting the cursor. Though it's not very complicated, is it? So, like, we could stick one of these ROMs here instead, though that would probably make that node completely useless. So then this would have like 3 output operations, which are render the top row of a character, render the bottom row of a character, and render 3 blank spaces, possibly. Does it have enough space that we could make it have operations for render an entire line of characters? Would that help? So why is it moving it to 0,1 anyway? It moves to 0,0 initially. Weirdo. So it would need about the same. If it was, yeah, it would need about. You would then want a loop that goes mov left up thing. 4 instructions, and then ideally a loop that goes mov 0 down. Though no, you don't need. We don't need to render an entire blank line. We render a blank line just by moving the cursor down. That's easy. So, kind of going, I don't quite know what the input format's going to look like now. So this one is probably going to do something like but maybe it wants to also do some counting or something. I kind of feel that maybe we'll do better by counting the input characters rather than trying to have a terminator. I don't know. So I think I'm actually fairly confident now that what I want to do is to move that code into that processor and change every occurrence of the word left to down. And then this one could do something like so then, and that's clearly a silly design, but so actually I think we want 3 operations that this output processor does, which are coordinate move, top half of a character, bottom half of a character. So let's stick that JRO at the top of the program where it ought to be. Right, so now, yes, it has 3 operations, which are either the x coordinate's always 0. It'll never want to move its cursor other than to the left margin. Which are move to some line, emit the top half of a character, or emit the bottom half of a character. And that seems like quite a good set of primitives for other processors to use. It's kind of sad that we've blocked that processor off and that one's fairly inaccessible. So I hope we can fit what I want to do in what's left. So let's now try emitting some actually... Let's try rendering some of what we've been asked to render, albeit without actually taking any input. So we would do that by going... well, actually, yes, but... Oh, gods, we do actually have to have a end-of-line sequence, don't we? Because we're meant to send a -1 in order to allow us to move the cursor again. Well, okay. 9, 10, 11, 12, 13, 14. Obviously, that really shouldn't be the last one, because that's a very rare case, and we want a common case at the end to give us that cheap jump. So we can go move to line 0, output the top line, top part of a 3, and the top part of a 4, move to line 1, oh no, sorry, end of line. Output the bottom half of a 3 and the bottom half of a 4. And stop. Right, so that should render those first two characters there. Yes. I mean, we've used an entire processor's worth of instructions to do it, but that's kind of a good start, I think. Meanwhile, this one's trying to load the input sequence. So then I think we have a process. I think first I've got 3 minutes till midnight and I should go to bed. So I think what we do is this input processor is some processor somewhere counts characters, detects new line, and does something on wrap or new line. So it should, as the characters come in, it should count them, and when it hits the full width of the screen, or when it gets an explicit new line, and note we don't know whether this terminal has pending wrap yet, which we might have to implement, then it triggers the procedure for emitting the bottom half of a pile of characters. And I don't know if this is going to be possible, but it might be. So we'll save this for now, and we'll come back to this maybe on Friday, maybe on Sunday, and try to finish it off. And Simon can help me with writing a terminal emulator, which is, I'm sure, what he always wanted to do. Until then, good night. Return to the segment list. Exit to the desktop. Good night.